Okay, so we start off with the mean value theorem in this section. So this has two criteria, not three, like the Rolle's theorem did. So it has to be continuous on the closed interval, that means including the endpoints, and differentiable in between, and then there's going to be a C in between that A and B, where this is happening. So let's look and see what this says. So this is saying slope of the tangent line at x equals c, right? And this is saying the slope of the secant line. Okay, so now I'm going to change this to application mode. Isn't slope of the secant line the same thing as saying average velocity? Like change in distance over change in time, right? Between the two different points, A and B. And isn't the derivative here the same thing as saying velocity at x equals c? Okay, so I'm going to give you a little story here, and I'll erase it, but so you don't need it. So I grew up in Canada, and in Canada you have to pay to drive on the highway. So you'd get on, and before you get on there would be a booth here, and you would get a ticket. And on this piece of paper would be the time and the place. The time you got on the highway and the place that you got on. All right, so we drive along the highway, and where I lived in Ontario, Canada, lots of cows and lots of corn. So just looking at lots of cows, lots of corn. So there weren't many, I lived in small towns, weren't many things to see around, so we'd drive past. My father had a lead foot. So before we would get off the highway to get to Grandma's house, many times we'd pull to the side of the road, and he'd tap his finger and wait and look at his watch, and we'd wait and we'd wait. Then he'd get back on the highway, and then we would get off. Because if we got off too quickly, and when he passed his ticket with the time and the place to the attendant in the booth, he could get a speeding ticket. What? How could they possibly know that he was speeding somewhere along the way? Well, since they knew the time and the place, couldn't they figure out the distance? And then couldn't they figure out the time? So they could figure out, by subtracting, they could figure out the distance divided by the time, and isn't that average velocity? Well, so what do they know? They know his average velocity was some number, 80 miles an hour, or there, it's kilometers per hour, 150 kilometers per hour. How do they know that in between he had to be going that speed? Well, that's what this mean value theorem says. So it's kind of mean. So if your average velocity is a certain number, that's what this is, then there will be a point in between at some time interval C, somewhere in between, where your velocity was that average velocity. All right, so that's the idea. So hopefully that will help you remember the mean value theorem. So let's move to doing this problem. Okay, so first we do have to, just like in Rolle's theorem, we have to make sure it satisfies the criteria. So the criteria first is this function, is this f of x continuous on the interval given? Yes, I can draw this graph without lifting my pen, right? That's what continuous is. So all good, check. All right, is this function differentiable on 0, 9? Oh, and it's a good thing that's open interval at 0 here, right? Because there's an endpoint at x equals 0, but they're not including that, so that's good. Check. All right, so now let's go find the C that satisfies the mean value theorem. So first I'm going to take the derivative. All right, so now I'm going to set the equation up here. So I'm going to put C into the derivative. So 1/2 C to the negative 1/2 equal. Now I'm going to use this for my A is 0 and my B is 9. So I'll have f of 9 minus f of 0 all over 9 minus 0. All right, so I'm going to go slow here. I'm going to put this negative exponent in the denominator. So this is root 9 minus 0, 9. So this gives me 3 over 9, so 1/3. Let's cross multiply, 3/2, c to the 1/2. And to undo this 1/2 power, I'm going to square both sides. So I get c is equal to 9 over 4. So double check that that number is in fact between 0 and 9. It is. So this is the value of c. So let's look at what this looks like on a picture. So if this was the graph of y equal root x, so let me draw my secant line. So my secant line, remember, is a line between 2 points, and the 2 points are x equals 0 and x equal 9. So this would be the secant line. So f of b minus f of a all over b minus a is the slope of the secant line. And so what this is saying is at this point c, and I'm just going to put it here, of 9/4, if I drew a tangent line there, it has the same slope as the secant line. So f prime of c, so let me erase this. So f prime of 9/4 equals the slope of the secant line, the red secant line, which is 1/3, right? Because I figured it out here. So the slope of the secant line I figured out right here, right? It's 1/3, and so the slope of the tangent line at 9/4 is 1/3 also.